everyone, welcome back to my channel. In this video, we are going to study about Lagrange's method of multipliers. First, let us understand the concept of Lagrange's method of multipliers. Sometimes, it is not required to find stationary points for more than one variables if they are given a specified conditions. In that case, Lagrange's method of multipliers help us to find stationary points subjected to some specified conditions. Let us suppose we have a function u of x, y, z which is to be maximized or minimized subject to the condition v of x, y, z which is equal to c. In that case, to find the Lagrange's method of multipliers, the steps are: first we have to form the auxiliary function f is equal to u of x, y, z plus lambda into v of x, y, z. This is an auxiliary function. First we have to form the auxiliary function. Using this auxiliary function, we have to find the values of x, y, z and lambda from the equation fx is equal to 0, fy is equal to 0, fz is equal to 0. Here fx is nothing but partial derivative of f with respect to x. Fy is nothing but the partial derivative of f with respect to y. Fz is partial derivative of a function, that is auxiliary function, with respect to z. We have to equate this fx, fy, fz to 0 and we have to find x, y, z and lambda value. After finding all these values, we have to substitute the value of x, y, z in the condition v of x, y, z which is equal to c. We get the stationary points. Here next step, substituting x, y, z values in v of x, y, z is equal to c, we get the stationary points. Here Lagrange's method of multipliers aim is to find the stationary points. After finding stationary points, the values of u of x, y, z are the maximum or minimum value for the function. Here, after obtaining stationary points, by substituting x, y, z values in the condition v of x, y, z is equal to c, then finally we have to substitute x, y, z values in a function u of x, y, z. We get the value of maximum or minimum value for the function u of x, y, z. These are all the working procedure to find Lagrange's method of multipliers. Let us solve some problems so that we can understand in a better way. Here is the first problem. Find the minimum value of x square plus y square plus z square when x plus y plus z which is equal to 3a. Here we have to find the minimum value for the function. Here this function is u, x square plus y square plus z square, subjected to the condition x plus y plus z is equal to 3a. This function is v. First take the function as u is equal to x square plus y square plus z square. Call this as equation number 1. Here this condition we can call this as v is equal to x plus y plus z. If we take 3a to the left hand side, that becomes x plus y plus z minus 3a. Call this as equation number 2. In previous classes, simply we studied how to find the maximum value or minimum value. But this problem is about to find the maximum value or minimum value of a function subjected to some particular conditions. Both are different. Understand carefully. Here what's the first step? We have to form the auxiliary equation. What's the auxiliary equation? F is equal to u of x, y, z plus lambda into v of x, y, z. We have to substitute u and v value for the auxiliary function. That is f is equal to u is x square plus y square plus z square plus lambda into v is x plus y plus z minus 3. After forming auxiliary function, we have to find fx is equal to 0, fy is equal to 0, fz is equal to 0. Here fx is nothing but partial derivative of f with respect to x. Here fy is partial derivative of f with respect to y. Fz is partial derivative of f with respect to z. First find fx and equate to 0. Here fx is nothing but differentiation of x square is 2x plus here y square plus z square is constant. So differentiation of constant is 0 plus lambda into differentiation of x is 1 plus here this becomes 0. Hence we get the value of fx as 2x plus lambda. We can equate to 0. Similarly find fy and equate to 0. We get the value as here f is this partial derivative of f with respect to y means this is differentiation of y square is 2y plus lambda into differentiation of y is 1. Hence we get 2y plus lambda which is equal to 0. Similarly fz is 2z plus lambda which is equal to 0. Here 2x plus lambda is equal to 0, 2y plus lambda is equal to 0, 2z plus lambda is equal to 0. Next step we have to find x, y, z and lambda value. Here 2x plus lambda is equal to 0. This implies lambda is equal to minus 2x. Similarly this lambda is equal to minus 2y. Here lambda is minus 2z. Here we get the value of lambda as minus 2x, minus 2y, minus 2z. Hence we can conclude that lambda is minus 2x, here also lambda is minus 2y, here also lambda is minus 2z. Hence we can take it as minus 2x, which is equal to minus 2y, which is equal to minus 2z. Or we can simply write it as x is equal to y is equal to z. Here minus 2x is equal to minus 2y, which is equal to minus 2z. Hence we can cancel minus 2 in these three terms. Hence we can simply write it as x is equal to y is equal to z. After obtaining x, y, z values, next substitute x is equal to y is equal to z in this condition v is equal to x plus y plus z minus 3a. We get the value as, here substitute in the place of y and z as x, we get as x plus x which is equal to 3a, which implies here x plus x is 3x, which is equal to 3a. Hence we can get as x value which is equal to a. Similarly, in the place of x and z substitute as y, we get the value of y as a. Similarly, substitute in the place of x and y value as z, we get the value of z value as a. Hence we get the value of x as a, y as a and z as a. After finding x, y, z values, to find the minimum value for the function x square plus y square plus z square means you have to substitute x, y, z values for this function u. Hence, the minimum value of x square plus y square plus z square, which is equal to, here in the place of x substitute as a, that is a square, plus in the place of y as a and z as a. Hence we get a square plus a square plus a square, which is equal to 3a square. This is a minimum value for the function u, that is x square plus y square plus z square, subjected to the condition x plus y plus z, which is equal to 3a. This is a procedure to find the minimum value or maximum value subjected to some condition. Here, to find the minimum value or maximum value means first step we have to form the auxiliary equation. After finding auxiliary equation, we have to form the equation as fx equal to 0, fy is equal to 0, fz is equal to 0. Using that equation, find lambda value. After finding lambda value, we get the value of xyz. We have to find the values of xyz means we have to substitute for the given condition. We get the value of xyz. After finding xyz value, we have to find the minimum value or maximum value. Substitute that values in the function u. We get the value of minimum value or maximum value for the function. This completes the problem. We shall move on to another problem. Find the maximum and minimum value of x square plus y square subjected to the condition 2x square plus 3xy plus 2y square minus 1. Here we have to find maximum value and minimum value for the function x square plus y square means take this u as x square plus y square, call this as equation number 1. Here subjected to the condition means 2x square plus 3xy plus 2y square minus 1. This is our v. Call this as equation number 2. What's the first step? We have to form the auxiliary equation, that is f is equal to u of, here we have the variables x and y, so we have to form the auxiliary function with respect to x and y only, that is f is equal to u of x comma y plus lambda into v of x comma y. Here u of x comma y is x square plus y square plus lambda into v of x comma y is 2x square plus 3xy plus 2y square minus 1. Next, we have to form the equation fx is equal to 0, fy is equal to 0. Here fx is nothing but differentiation of f partially with respect to x, that is differentiation of x square is 2x plus, here no x term, plus here 2x square differentiation is 4x plus differentiation of 3xy. Here 3y is constant, take as it is, into differentiation of x is 1. Hence we get 3y. That is fx is equal to 2x plus lambda into 4x plus 3y. Similarly, fy is partial differentiation of f with respect to y, that is differentiation of y square is 2y plus lambda into differentiation of 3xy, that is 3x is constant, take as it is, into differentiation of y is 1 plus differentiation of 2y square is 4y. This is our fy. Next step, we have to equate this to 0. We get the value of lambda as here 2x plus lambda into 4x plus 3y is equal to 0 means lambda is equal to, here this term to the right hand side, that becomes minus 2x divided by, here 4x plus 3y goes to the denominator. Hence we get lambda value as minus 2x divided by 4x plus 3y. For this function, lambda value becomes minus 2y divided by 3x plus 4y. Here this is how we form 2y plus lambda into 3x plus 4y is equal to 0. If we take 2y to the right hand side, that becomes minus 2y. If we take 3x plus 4y to the right hand side, that goes to the denominator. Hence we get lambda as minus 2y divided by 3x plus 4y. This is lambda is equal to minus 2x by 4x plus 3y. This also lambda is equal to minus 2y divided by 3x plus 4y. Hence we can equate this to equation. We get as minus 2x divided by 4x plus 3y, which is equal to minus 2y divided by 3x plus 4y. Here minus 2 gets cancelled, and equate these two equations, we get the value as here x into 3x plus 4y is 3x square plus 4xy, which is equal to here 4x plus 3y into y is 4xy plus 3y square. Here 4xy gets cancelled. The remaining is 3x square minus 3y square, which is equal to 0. Or we can take it as x square, which is equal to y square, that is 3x square is equal to 3y square. Here 3 gets cancelled, hence we get x square is equal to y square. Or we can take it as y is equal to plus or minus x. If we take square to the left hand side, that becomes square root of x square. We know that square root of x square is plus or minus x, that is our y value. Or we can take it as x is equal to plus or minus y. Both are same, y is equal to plus or minus x, or x is equal to plus or minus y. Here in the next step, we have to find the values for y is equal to plus x and y is equal to minus x. In next step, what's the next step? We have to substitute this condition to the value of v, that is v is equal to 2x square plus 3xy plus 2y square minus 1. Let's see how to do. First take, if y is equal to plus x, then equation 2 becomes, here equation 2 is this 2x square plus 3xy plus 2y square minus 1. Substitute in the place of y as plus x, we get as 2x square plus 3 into x into y is plus x plus 2x square, which is equal to 1. Here 2x square plus here 3 into x is x square. 2x square plus 3x square plus 2x square, we get the value as 7x square, which is equal to 1. Or we can take, if we take 7 to the right hand side, that becomes x square is equal to 1 by 7. Or we can take it as x is equal to square root of 1 by 7. Hence we get x is equal to plus or minus 1 by root 7. This is the value of x. Or if we take in the place of y is equal to plus x, if we take as x is equal to plus y and substitute in the place of x as y, we get the value of y as same as this, that is plus or minus 1 by root 7. Understand? If in the place of y is equal to plus x, we get the value of x as plus or minus 1 by root 7. Similar way, if we take the x is equal to plus y, if we substitute in the place of x as plus y, we get the value of y as plus or minus 1 by root 7. Hence, here x is equal to y. Hence, we get the value of x and y as plus or minus 1 by root 7. The stationary points are plus or minus 1 by root 7, comma plus or minus 1 by root 7. After finding stationary points, next step we have to find the extreme value, that is maximum value and minimum value. To find the extreme value means substitute x and y values in new function, that is x square plus y square. We get as x is 1 by root 7. Here x square is 1 by root 7 whole square. Here we can cancel square and root. We get the value as 1 by 7 plus here y is 1 by root 7. Hence y square is 1 by root 7 whole square. We get the value as 1 by 7. Here 1 by 7 plus 1 by 7, we get the value as 2 by 7. This is the extreme value for the function x square plus y square. In the similar way, for the case y is equal to minus x, equation 2 becomes, here substitute in the place of y as minus x, we get the value as 2x square plus 3x into, in the place of y substitute as minus x plus 2x square, which is equal to 1. Here 2x square plus 3x into minus x is minus 3x square plus 2x square, which is equal to 1. Hence we get as 4x square minus 3x square, we get the value as x square, which is equal to 1. Or we can take it as x is equal to plus or minus 1. Here x is equal to square root of 1, that is plus or minus 1 is a value of x. Here x is plus or minus 1, or we can take it as y is equal to plus or minus 1. That is, if we substitute x is equal to minus y in equation 2, we get the value of y as plus or minus 1. So we can take x and y values plus or minus 1 and plus or minus 1. Hence we can conclude that stationary points are plus or minus 1, comma plus or minus 1. And the extreme value for the case y is equal to minus x is substitute x value as 1 and y value as 1. We get as 1 plus 1 is 2. This is our extreme value. Hence we can conclude that maximum value is 2 and minimum value is 2 by 7. Here 2 by 7 is less than 2. Hence the maximum value is 2 and the minimum value is 2 by 7. This completes the problem. We shall move on to another problem. Find the extreme value of x into y subjected to the condition x square plus xy plus y square minus a square. First take u as xy, call this as equation number 1, and v as x square plus xy plus y minus a square, call this as equation number 2. First form the auxiliary function with respect to two variable xy, that is f is equal to u of x comma y plus lambda into v of x comma y. Substitute u value as xy plus lambda into v value as x square plus xy plus y square minus a square. After finding f value, then form fx, fy, fz, that is fx is partial derivative of f with respect to x, that is differentiation of xy is y plus lambda into differentiation of x square is 2x plus differentiation of xy is y. This is our fx. Similarly, fy is differentiation of f partially with respect to y, that means differentiation of xy is x plus lambda into, this is 0, differentiation of xy is x plus differentiation of y square is 2y. After obtaining fx, fy, equate these two functions to 0, we get lambda is equal to, here y plus lambda into 2x plus y is equal to 0, that becomes minus y divided by, here 2x plus y goes to the right hand side, that becomes divided by 2x plus y, that is our lambda is equal to minus y by 2x plus y. Similarly, lambda is equal to minus x by x plus 2y. Here lambda is minus y by 2x plus y, here lambda is minus x by x plus 2y. Hence we can equate these two values. We get as minus y by 2x plus y, which is equal to minus x by x plus 2y. Here minus minus gets cancelled, and equating these two equations we get as 2x plus y into x is here 2x square plus xy, which is equal to xy plus 2y square. Here xy gets cancelled. We get as 2x square is equal to 2y square, or we can take it as x square is equal to y square. Same as previous problem. Here x square is equal to y square, we can write it as y is equal to plus or minus x. After obtaining this equation, we have to find the values, that is stationary points at y is equal to plus x and at y is equal to minus x. For that, we have to substitute these values in equation number 2. Let's see how to find. First case, if y is equal to plus x, equation 2 becomes, here equation 2 is x square plus xy plus y square minus a square. Substitute y values plus x, we get as x square plus x into x plus x square is equal to a square. Here x square plus x into x is x square plus x square. Hence we get as 3x square is equal to a square. Or we can take it as, here this 3 goes to the right hand side, that becomes a square by 3, that is x square is equal to a square by 3, or x is equal to plus or minus square root of a square by 3, that is becomes a divided by root 3, that is our x value. Similarly, if we take x is equal to plus y, that is substituting x value as y in this equation number 2, we get the value of y as same, that is plus or minus a by root 3, that is x is equal to plus or minus a by root 3, y is plus or minus a by root 3. Hence we can take the stationary points as plus or minus a by root 3, comma plus or minus a by root 3. In the similar way, we have to find at y is equal to minus x, that is substituting y is equal to minus x. In equation 2, we get as x square plus x into minus x plus x square is equal to a square. Here x square plus x into minus x is minus x square plus x square is equal to a square. Here plus x square minus x square gets cancelled. The remaining is x square is equal to a square, or we can take it as x is equal to plus or minus a. Here x is square root of a square. We know that square root of a square is plus or minus a. X is plus or minus a. In the similar way, y is minus x. If we take x as minus y, substituting x value as minus y, we get the value of y as plus or minus a. Hence, we can conclude that the stationary points are plus or minus a, comma plus or minus a. Here, at y is equal to plus x, the stationary points are plus or minus a by root 3, comma plus or minus a by root 3. At y is equal to minus x, stationary points are plus or minus a, comma plus or minus a. After obtaining the stationary points, we have to find the extreme value of the function xy for y is equal to plus x. First, take the extreme values of the function xy for the case y is equal to plus x. For the value y is equal to plus x means substitute x value as a by root 3, y value as a by root 3, we get as a by root 3 into a by root 3 is a square divided by root 3 whole square is 3. Hence we get extreme value for y is equal to plus x as a square by 3. In the similar way, extreme value of x into y for the case y is equal to minus x is, here the stationary points are plus or minus a, comma plus or minus a. Substitute x value as a and y value is a. Here y is nothing but minus x, so we can take it as a into minus a. We get as minus a square. This is our extreme value. Hence we can conclude that the maximum value is, here a square by 3 is a maximum value and minus a square is a minimum value for the given function. This completes the problem. This is about how to find the maximum value or minimum value subjected to some specified condition. We shall move on to another type of problems, that is application of maxima and minima. We find maximum or minimum value of the function related to some general applications. Here is the first problem. A rectangular box open at the top is to have a volume of 32 cubic feet. find its dimension if the total surface area is minimum. These are all the problems related to the applications of maxima and minima. Here they have given the rectangular box open at the top is to have a volume of 32 cubic feet. Find its dimension if the total surface area is minimum. Here simply we can find the minimum value for the rectangular box open at the top is to have the volume of 32 cubic feet. Here rectangular box, for that we can consider a cube. Here this cube is a rectangular box. This is x-axis, this is y-axis, this is z-axis. Here they have mentioned the volume of the rectangular box is 32 cubic feet. Here the volume of the rectangular box is 32 cubic feet with respect to some condition, that is this rectangular box open at the top. Here one side of the box is opened. For this we have to find the dimension if the total surface area is minimum. We have to find the dimension of this rectangular box. First let us see what are all the given conditions. Here we have to consider the rectangular box means let x, y, z are the length, breadth and height of the rectangular box. Here x value is length, y value is breadth and z value is height of the rectangular box. In the similar way, let v be the volume and s be the surface area of the box. Since it is a rectangular box, the volume of the box is denoted by v and the surface area of the box is denoted by s. We all know that the volume of the cube is given by v is equal to x into y into z. Here x, y, z are length into breadth into height. That is our volume. They have mentioned the volume of the rectangular box is 32 cubic feet. Hence we can take it as v is equal to x into y into z, which is equal to 32. This is our volume. Call this as equation number 1. In the similar way, we know that the total surface area is 2 into length into breadth plus breadth into height plus height into length. This is a general formula of total surface area of the cube, that is 2 into xy plus yz plus zx. Also they have given the rectangular box is open at the top. Since the box is open at the top, the corresponding surface area is, here the total surface area is 2 into xy plus yz plus zx. But since the rectangular box is open at the top, we have to take the value of surface area as s is equal to 2xy plus 2yz plus 2zx minus xy. We have to subtract this total surface area with any one of the surface, that is we get as 2xy plus 2yz plus 2zx minus xy, or we can take it as 2xy plus 2yz plus 2zx minus yz also or zx also. We get the value as s is equal to xy plus 2yz plus 2zx. This is our s value. Here they have in the problem they have mentioned simply a rectangular box open at the top is to have a volume of 32 cubic feet. Find its dimension if the total surface area is minimum. Simply they have given like this. Using this problem, we have to find v and s value like this. That is, here we have to find the rectangular box means the volume of the rectangular box is given by x into y into z. They have given the volume of the box as 32 cubic feet. Hence we can take v as xyz, which is equal to 32. Call this as equation number 1. Also we know that the total surface area of the cube, that is rectangular box, is given by 2 into xy plus yz plus zx. This is a general formula to find the surface area. 2 into xy plus yz plus zx. Since the box is open at the top, the corresponding surface area is, you have to subtract this total surface area with any one of the surface. We get the value of s as xy plus 2yz plus 2zx. Hence we have to find the s is minimum subjected to the condition xyz is equal to 32. This is our aim, that is to find s is minimum subjected to the condition xyz is equal to 32. In previous problems they have mentioned u and some condition directly, but in this problem they have given the question we have to find v, that is volume, and again we have to find the surface area, and we need to find the surface area, that is s is minimum subjected to the condition, that is xyz, which is equal to 32. Now we can find the values using previous method. That is, what is the first step? We have to form the auxiliary equation, that is f is equal to, here we contain xyz 3 variables, that is, hence we get f is equal to u of xyz plus lambda into v of xyz. Here we know that u of xyz is xy plus 2yz plus 2zx plus lambda into, here the condition is v of xyz. Here what's the condition is xyz. Hence we get lambda into xyz. This is our f. Next find fx, fy, fz and equate to 0. We get this. Here fx is, here differentiation of f partially with respect to x is, the differentiation of xy is y plus, here this value becomes 0 plus differentiation of 2zx is 2z plus lambda into differentiation of xyz with respect to x partially means y into z, which is equal to 0, that is fx is equal to 0. In the similar way, fy is differentiation of f partially with respect to y, that is x into y differentiation is 1 plus 2 into z plus lambda into the differentiation of xyz is x into z, which is equal to 0. Similarly, fz is differentiation of f partially with respect to z. Here this is 0. Here this value is 2y plus 2x plus lambda into x into y, which is equal to 0. Here fx equal to 0, fy is equal to 0, fz is equal to 0. From these three equations, if y plus 2z plus lambda into yz is equal to 0, which implies lambda is equal to, here if we take y plus 2z to the right hand side, that becomes minus y plus 2z. If we take yz to the right side, we get divided by yz. Hence we get lambda is equal to minus y plus 2z by yz. Similarly, if we take x plus 2z plus lambda into xz is equal to 0, we get the value of lambda as minus x plus 2z divided by xz. In the similar way, 2y plus 2x plus lambda into xy is equal to 0. Hence we get lambda value as minus 2y plus 2z divided by xy. Here lambda is minus y plus 2z by yz. Here lambda is our minus x plus 2z by xz. Here lambda is minus 2y plus 2z. Lambda is minus 2y plus 2x divided by xy. Hence we can conclude all these three values are equal. To find xyz value, first consider these two equations and equate the values we get as, here xz into minus y plus 2z is xyz. Here minus minus gets cancelled. Here xyz plus 2z into xz is 2xz square, which is equal to x into yz is xyz plus 2z into yz is 2yz square. Here xyz gets cancelled. The remaining is, here also 2xz square is equal to 2yz square. Here 2z square gets cancelled. The remaining we get as x is equal to y. Here considering first two equation, we get the value as x is equal to y. Next we have to consider these two equation and equating, we get the value as, here minus minus gets cancelled. X into xy is x square y plus 2z into xy is 2xyz, which is equal to 2y into xz is 2xyz plus 2x into xz is 2x square z. Here also 2xyz gets cancelled. The remaining is here x square y, which is equal to 2x square z. Here x square gets cancelled. The remaining is y is equal to 2z. Here y is equal to 2z. Also this y, that is x is equal to y from the first two equation and y is equal to 2z. Hence we get the z value as, here y is equal to 2z means z is equal to y by 2, which is equal to, here in the place of y we can write it as x by 2. Here y is x. Hence we get z value as y by 2 or x by 2. This is our z value. Hence we can conclude that x is equal to y and y value which is equal to 2z. Take x is equal to y is equal to 2z value which is equal to some k. To find x, y, z value, we have to put like this, that is x is equal to y. You already know from this two equation we get the value as x is equal to y. This y which is equal to 2z again, that is x is equal to y is equal to 2z, which is equal to, take some value k. Hence we get x is equal to y is equal to 2z, which is equal to k. Hence we get x is equal to k, y is equal to k and z is equal to k by 2. If we take 2 to the right hand side, that becomes k by 2. Hence this is the value of x, y, z. Again we have to find k value and substituting k value here we get the value as x, y, z. For that, substitute x is equal to k and y is equal to k and z is equal to k by 2 in equation number 1, that is v is equal to xyz is equal to 32. We get the value as, here x is k and y is k, z is k by 2, which is equal to 32. Hence we get k into k into k is k cube divided by 2, which is equal to, we get this as k cube divided by 2, which is equal to 32. If we take 2 to the right hand side, that becomes 32 into 2. Hence we get k cube, which is equal to 64. Or we can take k value as 4. Here cube root of 64 is 4. Hence we get k value as 4. Once we get the value of k as 4, substitute k value as, here we get the value of xyz as, hence we get the value of xyz as k is 4, hence we get x is 4, y is 4 and z is k by 2, that is 4 by 2, which is equal to 2. This is our xyz value, that is stationary point value is 4, 4, 2. Understand? First we have to form the auxiliary equation. From that find fx, fy, fz and equal to 0. We get 3 equation here. First take first 2 equation and find the value. Similarly take second 2 equation and find the value. After obtaining all the value we get like this, x is equal to y is equal to 2z. Take this 3 equation which is equal to k and find the value of k as this, k is equal to 4. We get, substituting k as values 4 over here, we get the value of xyz as 4, 4, 2. This is a stationary point. Also we have to find minimum values of s subjected to the condition v is equal to xyz is equal to 32. For that, substitute x is equal to 4, y is equal to 4 and z is equal to 2 in the value of s, that is s is equal to xy plus 2yz plus 2zx. We get as, here x is 4 and y is 4, hence we get 4 into 4 is 16 plus 2 into 4 into z is, here z is 2, hence we get 2 into 4 is 8, 8 into 2 is 16 plus 2 into 4 is 60, hence we get s value, minimum s is 16 plus 16 plus 16, hence we get s as 48 square units. This is a minimum value of s. This completes the problem. We shall move on to another problem so that you can understand in better way. Find the dimension of rectangular box open at the top of maximum capacity whose surface is 432 square centimeter. Here, first write the given terms, that is, let xyz are the dimension of open rectangular box. Here x is length, y is breadth and z is height respectively. Here given the total surface area of rectangular box is 432 square centimeter. We know the total surface area of rectangular box open at the top is given by xy plus 2yz plus 2zx. That value which is equal to 432 square centimeter. Call this as S, that is surface area. We can write it as S is equal to xy plus 2yz plus 2zx, which is equal to 432 square centimeter. Let V be the volume of the box. That is, rectangular box, the volume is given by x into y into z sides. Multiplying all these sides, we get the value of volume. That is, volume of the box is V, which is equal to x into y into z. Hence, we have to find the maximum value of V subjected to the condition xy plus 2yz plus 2zx, which is equal to 432 square centimeter. In this problem, u function is this xyz and v function is this. You have to note carefully. In previous problem, u function is xy plus 2yz plus 2zx and v function is xyz. But in this question, u function is this, that is x into y into z, and v function is xy plus 2yz plus 2zx. Now to understand carefully, here we need to find v is maximum subjected to the condition. Here condition is this and the function is this, that is x into y into z. What's the first step? We have to form an auxiliary equation like this, that is f is equal to u of x comma y comma z plus lambda into v of x comma y comma z. Here u function is this, that is x into y into z is our u. Here v of x comma y comma z, that is condition is this. You have to write carefully. Substituting u and v values, we get as u is x into y into z plus lambda into v is xy plus 2yz plus 2zx. Next step, find fx, fy, fz and equate to 0. We get as, first find fx, that is fx is equal to, here differentiation of f partially with respect to x, that is yz plus lambda into y plus, here this value becomes 0 plus 2z. This is our fx, equate to 0. Similarly, fy is here x into z plus lambda into x plus 2z, which is equal to 0. Similarly, fz is xy plus lambda into, here this value becomes 0 plus 2y plus 2x, which is equal to 0. This is fx, fy, fz. Here yz plus lambda into y plus 2z is equal to 0. From that we can take lambda is equal to, here yz goes to the right hand side, that becomes minus yz divided by, here y plus 2z goes to the denominator, that is lambda is equal to minus yz by y plus 2z. Similarly, for this function, lambda is equal to minus xz divided by x plus 2z. For this function, lambda is equal to minus xy divided by 2x plus 2y. Here we have to write the lambda values carefully. Here all these values are lambda, hence we can conclude that minus yz by y plus 2z, which is equal to minus xz by x plus 2z, which is equal to minus xy by 2x plus 2y. Consider first two equation, cross multiply these two equations, we get the value as here x into y is xy plus 2yz, which is equal to y into x is xy plus 2xz. Here plus xy plus xy gets cancelled, and here 2yz which is equal to 2xz, here 2z gets cancelled, hence we can take it as x is equal to y. Similarly, take these two equations, we get as here minus x gets cancelled here itself. Cross multiply these two equations, we get the value as here z into 2x is 2xz plus z into 2y is 2yz, which is equal to x into y plus 2yz. Here plus 2yz, here also plus 2yz gets cancelled, and here 2xz, here xy. Hence we can cancel this x term, and the remaining is z is equal to y by 2. Here the remaining is 2z is equal to y. Hence we can take z value as y by 2, which is equal to, here y is nothing but x. Hence we get y by 2 as x by 2. This is our z value. Hence this is x is equal to y, and that y value which is equal to z. From these two equations we can write it as x is equal to y, which is equal to y is nothing but here y is nothing but 2z. Hence we get y is equal to 2z, x is equal to y, and y is equal to 2z. Now in the next step, to find x, y, z value, what's the step? We have to take these values which is equal to k. Then we get the value of x as k, and y is k, and z is k by 2 as before. Here substitute x is k and y as k, and z is equal to k by 2 in the value of s, that is xy plus 2yz plus 2zx, which is equal to 432 square centimeter. We get as x is k and y is k plus 2 into k into z is k by 2 plus 2 into z is k by 2 into k, which is equal to 432 square centimeter. Hence we get k into k is k square plus here 2 gets cancelled, here also 2 gets cancelled, the remaining is k square plus here also k square, here also k square. Hence we get 3k square is equal to 432. If we take 3 to the right hand side, that becomes k square is equal to 432 divided by 3. Hence we get the value as 144. K square is equal to 144, which implies k value which is equal to 12. 12 into 12 is 144. Hence we get k value as 12. After finding k value as 12, substitute k value as here, we get the value of x, y, z as here. Therefore, the value of x by z is x is 12, y is 12, and z is 12 by 2 is 6. This is a stationary values, that is x is 12, y is 12, and z is 6. This is stationary points. After finding stationary points, you have to find the maximum value. For that, consider the function v is equal to x into y into z, that is u function. You have to consider u function, not v function. This u and v are nothing but auxiliary function. Standard definition, that is u of x comma y comma z in first function, v of x comma y comma z are these specified conditions, but u of x comma y comma z are given function. So we have to find the maximum value for the given function u. Here u is nothing but our v, hence we get v is equal to x into y into z. Substitute x value as 12, y value as 12, and z value as 6. We get the value as 864 square centimeter. This is a value of maximum value v. This completes the problem. Here is another problem. Show that rectangular box of maximum volume and a given surface area is cube. Here in this problem they have not given directly. Instead we have to show that the rectangular box of maximum volume and the surface area is cube. For that, for a rectangular box, let x comma y comma z are the dimension of rectangular box having volume v and surface area s. Here for the rectangular box, x, y, z are dimension, that is x is length, y is breadth, z is height. Volume of the rectangular box is given by v and the surface area is given by s. Therefore, we can conclude that the volume is given by x into y into z and the surface area is 2xy plus 2yz plus 2zx. In this problem, they have not mentioned rectangular box open at the top. Hence, we have to consider the general formula, that is rectangular box is nothing but a cube, that is surface area, total surface area of a cube is given by s is equal to 2 into length into breadth plus 2 into breadth into height plus 2 into height into length. This is a general formula. Also, volume is given by x into y into z. In this, we have to show that rectangular box of maximum volume and the given surface area, here surface area is cube, we have to show that surface area is cube. Hence we have to take u function as x into y into z and v function as 2xy plus 2yz plus 2zx. Here first step we have to form the auxiliary equation, that is f is equal to u of x comma y comma z plus lambda into v of x comma y comma z. Here we have to show that the surface area is cube Hence we have to take this is a condition. Hence take the surface area, that is S, as V, and the function as x into y into z. This is our u as xyz and v as s. Since we have to show that the surface area is cube, take this is a condition, that is v of x comma y comma z. Substituting the values, we get as u is xyz plus lambda into v is 2xy plus 2yz plus 2zx. Here first step, fx, fy and fz which is equal to 0, we have to find that. That is fx is equal to, here differentiation of f partially with respect to x is yz plus lambda into 2y plus, here this value becomes 0 plus 2z which is equal to 0. Similarly, fy is partial differentiation of f with respect to y, that is xz plus lambda into 2x plus 2z which is equal to 0. Similar way, fz, that is partial differentiation of f with respect to z is xy plus lambda into, this value becomes 0 plus 2y plus 2 into x which is equal to 0. Hence we get the lambda values as lambda is equal to, here yz goes to the right hand side, that becomes minus yz divided by 2y plus 2z goes to the denominator. If we take 2 as common, we get as 2 into y plus z, that is our lambda. Similar way, lambda is equal to, here minus xz divided by 2 into x plus z. Here also lambda is equal to minus xy divided by 2 into x plus y. Here all these three equations are lambda, hence we get the value as minus yz by 2 into y plus z which is equal to minus xz by 2 into x plus z which is equal to minus xy by 2 into x plus y. First step, we have to take these two equations, we get the value as, from these two equations we can cancel minus z, hence the remaining is, by cross multiplying these two equations we get the value as, here only we can cancel the two terms and cross multiply, or we can write like this also. Here 2x into y is 2xy plus 2yz which is equal to 2xy plus 2xz. Here plus 2xy gets cancelled. Here 2yz which is equal to 2xz. Here also 2z gets cancelled. The remaining is x is equal to y. In a similar way, take second two equation, that is minus xz by 2 into x plus z which is equal to minus xy by 2 into x plus y. Here cancelling minus x, and here also we can cancel two term and write, or write like this also. We get the value as 2x into z is 2xz plus 2y into z is 2yz which is equal to 2x into y is 2xy plus 2z into y is 2yz. Here 2yz gets cancelled and 2x gets cancelled. The remaining is y is equal to z. From the first two function we get the value as x is equal to y, and second two function we get the value as y is equal to z. Therefore we can conclude that x is equal to y and y is equal to z. Therefore the rectangular box of maximum volume and the given surface area is cube. This concludes that the rectangular box of maximum volume and given surface area is cube, because length is equal to breadth is equal to height. That concludes rectangular box of maximum volume and given surface area is cube. Next step, to find the stationary points, substitute x is equal to y is equal to z in the value of v, that is put x is equal to y is equal to z in v is, here v is 2xy plus 2yz plus 2zx which is equal to, call some value a, substitute x is equal to y is equal to z, that means substitute yz value as x or xy value as z or xz value as y, any one of the condition. Here 6x square is equal to a, hence we get x value as square root of a by 6. Hence the maximum value of v which is equal to x into y into z, substitute here x is square root of a by 6, here x is equal to y equal to z, that becomes, here y value is also equal to root of a by 6, z value is also root of a by 6, hence we get, multiplying all these values we get the value as, here root of a by 6 into root of a by 6 is root of a by 6 whole square. Simply we get the value as a by 6 into root of a by 6, that is a by 6 into root of a by 6. This is a maximum value of v. This completes the problem. Here is another problem. If x comma y comma z are the angles of triangle, find the maximum value of sin x into sin y into sin z. First take the given problem, that is, first you have to take the solution. Here we need to find the maximum value of sin x into sin y into sin z. We have to find the maximum value for the function, means this is our u, such that XYZ are the angle of the triangle. That means angles of the triangle are given by x plus y plus z, which is equal to pi. So this is our V. This condition is our V, and we need to find the maximum value for the function, means this is our U. Sin x into sin y into sin z. Here in the problem, they have not given directly. We have to find the values of U and V. Here they have mentioned x, y, z are the angles of the triangle. Angle of the triangle is given by the formula x plus y plus z, which is equal to pi. And we have to find the maximum value for the function sin x into sin y into sin z, means this is our U. First step, form the auxiliary equation, that is f is equal to u of x, y, z plus lambda into v of x, y, z. Here u is the sin x into sin y into sin z plus lambda into v is the x plus y plus z. Here find fx, fy, fz first and equate to 0. Here fx is, here sin y into sin z is constant, differentiation of sin x is cos x. Hence we get cos x into sin y into sin z plus lambda into, here differentiation of x is 1, hence lambda, which is equal to 0. If we equate to 0, we get the lambda value as, here lambda is equal to, if we take this to right hand side, that becomes minus cos x sin y sin z. In similar way, fy is, here sin x and sin z are constant, hence we get sin x into cos y into sin z plus lambda into differentiation of y is 1, which is equal to 0. Hence we get lambda as minus sin x cos y sin z. Similar way, fz is, here sin x and sin y are constant, into differentiation of sin z is cos z plus lambda into z into differentiation is 1, which is equal to 0. Hence we get lambda as minus sin x into sin y into cos z. Here these three are our values of lambda. Hence we get the equation as cos x sin y sin z, which is equal to sin x cos y sin z, which is equal to sin x sin y cos z. If we can cancel all the negative signs. In next step, consider first two function, that is cos x into sin y into sin z, which is equal to sin x cos y sin z. From these two equation we can cancel sin z sin z. The remaining is cos x sin y. If we take sin x cos y to the left hand side, that becomes minus sin x cos y, which is equal to 0. Here this we have to note that this is of the form sin of a minus b. We know that sin of a minus b is sin a cos b minus cos a sin b. Here also same form, that is sin a cos b minus cos a sin b. Here a is y and b is x, hence we can write it as sin of y minus x, which is equal to 0. Sin of y minus x, which is equal to 0, which implies y minus x, which is equal to sin inverse 0. We know that sin inverse 0 is, that is sin value becomes 0 at the value 0 degree. Hence we get y minus x is equal to 0, hence we get y is equal to x. Similarly, consider these two equations and cancel sin x, we get the value as cos y sin z, and take sin y cos z to the left hand side, that becomes minus sin y cos z, which is equal to 0. Here this is also same, that is sin of a minus b is sin a cos b minus cos a sin b. Here a is z and b is y, hence we get sin of z minus y, which is equal to 0, or z minus y, which is equal to sin inverse 0. We know that sin inverse 0 value is 0, hence we get z minus y is equal to 0, that becomes z is equal to y. Here y is equal to x, that is x is equal to y and y is equal to z. Therefore, we can conclude x is equal to y is equal to z. Also, we know that x plus y plus z value, which is equal to pi. Substituting x is equal to y is equal to z in this equation, we get the value as, here x plus, in the place of y we can substitute as x, here in place of z we can substitute as x. Hence we get x plus x is 3x, which is equal to pi, which implies x is equal to pi by 3. In the similar way, if we put all the values as y, we get the value as y value is pi by 3 and z value is also equal to pi by 3. That is, since x is equal to y is equal to z, we get the value as pi by 3. X value is pi by 3, y value is pi by 3, z value is pi by 3. Substitute all these values in the function u, we get the maximum value of u. That is, u is equal to sin x into sin y into sin z. Substitute x, y, z value as pi by 3, we get the value as sin pi by 3 into sin pi by 3 into sin pi by 3. We know that sin pi by 3, that is sin 60 degree value is root 3 by 2. That is root 3 by 2 into root 3 by 2 into root 3 by 2, which is equal to root 3 by 2 whole cube. That becomes here root 3 by 2 whole cube. We can split it as root 3 into root 3 whole square. Hence we get 3 root 3 divided by 2 cube is 8. Hence we get the maximum value as 3 root 3 by 8. This completes the problem. These are all some problems related to application of maxima or minima. Till here we study about Lagrange's method of multipliers and problems on application of maxima and minima.